So today we're going to look at examples from Chapter 5, Section 6. And the first one is asking us to compare EF to FG. So when I look at those two, I notice that they are each part of a triangle. And so I'm going to kind of continue my highlighting, and I'm going to highlight this entire triangle that includes EF as triangle EFH. And then I'm going to go back to my blue, and I'm going to highlight this triangle as triangle GFH. And so what that allows me to do is kind of pull them apart and see them as two separate triangles without redrawing them. So I need to start to piece together some information about each of these triangles. And I need to use the fact that they are connected to my benefit. So for example, I notice that I have a measurement here of 82 degrees for angle EHF. And if EHF is 82 and its linear pair is over here at GHF, that means that I can take 180, subtract the 82 degrees, that is angle EHF, and get the measurement of angle GHF, which is 98 degrees. Paper over a little bit. That is the measurement of angle GFH. So now that I know, maybe I can zoom in a little bit. Now that I know that that is 98 degrees, I'm going to focus on the other information that I have. The other information I have is that on the yellow triangle, segment EH is equal to the segment on the blue triangle, GH. Oops, I shouldn't have put a line above there because we were talking about measurements. Sorry. So EH is 7 and so is GH. So far, each of these triangles has one side in common. I also know that they each share the segment FH, which is obviously, because of reflexive, equal to FH. So if I know that they each have two sides in common, and I'm comparing EF and FG, which usually means is it greater than, less than, or equal to, what I can compare with the hinge theorem is that because 98 degrees is a larger angle than 82, then this side that is opposite that is longer than this side here that is opposite 82. So my final conclusion is that by the hinge theorem, I'm going to move my paper over one more time. By the hinge theorem, segment EF is less than segment GF. Now on to the second example. We're going to compare the measurement of, here comes my highlighter, the measurement of BAC. So we're looking at this angle here to the measurement of DAC, this angle right here. So we're going to, I think this time I'm going to go through and put some congruency marks, because now we've got a similar thing happening as we had last time. We've got a side here that is congruent to a side here. We have this side here, which I'm going to mark it even though it's kind of silly, with the reflexive property. We have a second side to these two triangles that is congruent. And then what I notice is I have an angle here, 7, that is opposite, get my yellow pen, opposite angle BAC. And I also have an angle, or excuse me, a measurement 6 that is opposite angle DAC. Now similarly in the last example, if we kind of set up the pieces that are similar, for example, that segment AB is equal to the measurement of segment AD, lost my train of thought. We also set up that we know the two segments AC that are shared by each triangle are congruent to one another. Then we're focused on this third side, this BC, which is larger or longer than DC. And then what we're allowed to say is the converse of the hinge theorem, the one that goes backwards from what we did before, would say that if the side 6 is shorter, then the angle DAC is smaller than the angle opposite 7, BAC. So the converse of the hinge theorem allows us to say that the measurement of angle BAC is larger than the measurement of angle DAC. Okay, our last two examples are going to be some proofs that utilize the hinge theorem. And so we're going to pay attention to this shape first, and then I'll move over and I'll sort of design my proof on the right-hand side. So I'm going to do my usual highlighting, and I'm going to say that even though it's marked as congruent, AB, I will mark in yellow, is congruent to CD. Then we also see that they're telling us the measurement of ABD, so this angle here at the top, is larger or greater than the measurement of CDB. So we're really focusing in, as I use my pen, on the relationship between this angle here and this angle here. Now I probably shouldn't use those markings because that would imply they're congruent, but I'm just going to do that for color coding purposes. So now what we have to do is prove that AD, the unmarked side, is actually larger than CB. So this is going to be a pretty easy proof because it goes directly with the hinge theorem. I'm going to move my drawing over, move my highlights with it. I don't know why it does that. And I'm going to start setting up a proof. Remember your proofs, they can't be that long ago. I'm going to put my statements and my reasons over here. And so for my first statement, I'm going to restate the givens. I'm going to state that AB is congruent to CD and that the measurement of angle ABD is greater than the measurement of angle CDB. Those are my given. The second thing I'm going to look at is that there is a shared side here. Side BD, right, is a side for each of these triangles, and that is the second side they have that is congruent because of the reflexive property. So I'm going to state that. Remember, we have to state everything even if it's obvious. BD, segment BD, is congruent to segment BD, and that is the reflexive property of congruence. Okay, and then the third thing that I can say now, this is where it becomes really easy, is that segment AD, the measurement of segment AD, is surely larger than the measurement of segment CB because of the hinge theorem. Now, the reason that all worked so nicely is that the hinge theorem talks about the fact that you've got two sets of congruent sides, and you've got an included angle in those sides that are not congruent. So we've already established with the given that we had one congruent side out of 3. We had the included angle as larger, ABD was larger than CDB. We just had to prove that their other side around each of those angles, segment BD, was congruent in each of these triangles, and then we were allowed to say that the angle that they deemed was larger, ABD, the green one, was opposite the segment that is longer or larger. So the hinge theorem says that if we have these two sides and an included angle, the side opposite the larger angle is indeed the longer or larger side. In our last proof, we've got some information about our angles. Angle SRT, so this one right here, is congruent to angle STR. Okay, and then we've got information that side TU, or segment TU, is actually bigger than segment RU. And we're going to have to use the converse of the hinge theorem because we're going to be using the measurement of sides to prove that the measurement of angle TSU is actually greater than the measurement of RSU. Okay, so typically I would say draw these two triangles separately, but I'm going to keep them together, and I think when you look at the proof, you might be able to tell why. Okay, I've got my statements and my reasons columns created and the given already recorded to save time. And I want to take a look at some of the given information about the angles and how I'm going to use that. So I've got congruent angles on either side of this little top triangle that is separate from the two that we're kind of looking at. The two we're looking at are a little bit larger, but I'm going to use these two triangles because what I know in the converse of the isosceles triangle is if I have two angles here opposite one another here that are congruent, then the sides that are opposite them are congruent as well. So I am able to confidently say that segment ST is congruent to segment SR. And that is because of the converse of the isosceles triangle theorem. The original isosceles triangle theorem talked about the relationship between the sides and how it determines the angles. So the converse is how the angles determine the sides. And after I know that, then what I've established already is that I've got this side and this side of the larger triangles that are congruent. And now I want to show that this side, through the reflexive property, is congruent to itself. So I'm going to say that SU is congruent to SU, and that is the reflexive property of congruence. And now that I've established the two sides, this side and this side are congruent, I'm focused on the angle that is included by each of those sides. And the information I was given is that TU, the side that we highlighted in blue, is larger, which would mean automatically that the angle TSU, which is opposite that, is going to be larger as well. So our fourth step is to say that the measurement of angle TSU is greater than the measurement of angle RSU, with the reasoning being the converse of the hinge theorem.